Hello, and welcome to the AI Research Roundup. I am Alex, and today is May 12th, 2025. Alright, today we are looking at a research paper from Hugging Face's trending list, published 9 days ago, titled Beyond Recognition, Evaluating Visual Perspective Taking in Vision Language Models. This paper investigates vision language models, AIs that understand both images and text, and their ability to perform visual perspective taking, or VPT. Visual perspective taking is the skill of understanding what another entity sees, or how objects appear from their viewpoint. The research uses carefully designed visual tasks to test this. Okay, so this first figure really sets the stage. It is a bar chart showing prediction correctness, a precision-based measure of how often different vision language models got answers right across 3 task categories. These are scene understanding, then spatial reasoning, and finally, visual perspective taking. What is striking is the performance drop. Models excel at basic scene understanding, but their accuracy significantly decreases for spatial reasoning and plummets for visual perspective taking, with some nearing the random classifier baseline shown by the dashed line. This visual clearly highlights the core challenge for these models. Building on that performance overview, this next figure illustrates the actual visual tasks. We see 16 different scenes, each with a humanoid minifigure, a small toy figure, and a single object. The researchers varied object placement, the minifigure's orientation facing towards or away from the object, and the camera angle, which was either surface level or a bird's eye view. These controlled variations allowed for systematic testing of the vision language models using open-ended diagnostic questions, which are questions designed to elicit detailed responses, revealing the model's reasoning processes. This table then details those open-ended diagnostic questions. It is organized by the cognitive skill being tested, scene understanding, spatial reasoning, and visual perspective taking. For each question, it lists the specific ability, like mental rotation, which is the ability to imagine an object turned around in 3-dimensional space, and an example answer from GPT-4 Turbo. Crucially, questions Q6 and Q7 directly probe visual perspective taking, with Q6 testing if the minifigure sees an object, known as Level 1 visual perspective taking, and Q7 asking about the object's location from the minifigure's viewpoint, which is Level 2 visual perspective taking. Okay, so this table lays out the concrete prediction correctness scores for each of those diagnostic questions. Across the top, we have various vision language models, including GPT-4o, Claude 3.5 Sonnet, and GPT-4 Turbo. As expected from our earlier discussion, scene understanding scores for Q1 through Q3 are very high. Then, for spatial reasoning, Q4 and particularly Q5, the accuracy drops, and for visual perspective taking, the scores for Q6, which is Level 1 visual perspective taking, and especially Q7. Level 2 visual perspective taking fall sharply, really underscoring the difficulty these models have with those more advanced tasks. Alright, so digging deeper into those challenging questions, this figure presents co-occurrence matrices. A co-occurrence matrix is essentially a grid that visualizes how often a model's predicted answer aligns with the actual correct answer. The top row of these grids corresponds to question Q5, which is about determining the minifigure's orientation, and the bottom row relates to question Q7. Level 2 visual perspective taking. We can see distinct patterns of errors here. For example, some models exhibit a noticeable directional bias for Q5, and nearly all struggle to accurately pinpoint object locations from the minifigure's perspective for Q7. These visualizations pinpoint the specific error types. Following those error analyses, the researchers then explored if giving the models a bit of help would improve their visual perspective taking. This next bar chart shows just that. It compares the prediction correctness for question Q6, which is Level 1 visual perspective taking, for several models, including GPT-4o and Claude 3.5 Sonnet. The lighter bars represent the baseline performance, while the darker bars show performance when the models were explicitly told the minifigure's correct orientation. Interestingly, even with this direct hint, the improvement in prediction correctness is only marginal across all tested models. So to wrap up our discussion on this insightful research, it is clear that current vision language models, which are AI systems designed to process and understand both visual information and text, are quite good at basic scene recognition. However, they significantly struggle with more complex spatial reasoning, and particularly with visual perspective taking. That is, understanding what another entity sees or how things appear from a different viewpoint. This really points to a need for developing future models that can build better internal geometric understandings of the world. Thanks for tuning in to the AI Research Roundup.